Deep in the Libyan desert, at a sandstone plateau named Gilf Kebir, ancient cave paintings depict human figures swimming in calm water. Surrounding these painted swimmers are clear images of hippopotamuses, giraffes, and cattle grazing on lush grass. 500 miles south at the Kebir archaeological site in Niger, researchers excavated more than 200 human graves alongside harpoon tips carved from bone. Burial sites sat directly above giant catfish skeletons and thick layers of freshwater lake sediment. 6,000 years ago, Lake Megachad spanned over 360,000 square kilometers across Central Africa. It was larger than all 5 North American Great Lakes combined, reaching depths exceeding 100 meters in its central basin. Sediment cores extracted by ocean drilling ships off the coast of Mauritania confirm this aquatic landscape was not a temporary anomaly. Chemical analysis of ancient leaf waxes proves North Africa enjoyed continuous humid vegetation from 11,500 to 5,500 years ago. For centuries, European cartographers and geographers believed the Sahara had been a burning wasteland for millions of years without interruption. They viewed the desert as a permanent, immutable geographic boundary separating northern Africa from the tropical sub-Saharan interior. Hungarian explorer Laszlo Almásy shattered this conventional belief during his 1932 expedition into the uncharted eastern Sahara. His discovery of rock art in remote wadis provided undeniable proof that human communities once flourished where annual rainfall is now practically zero. Radiocarbon dating of organic matter preserved beneath desert sands revealed a sudden, dramatic shift across the entire region. What was once a continent-spanning network of lakes and rivers vanished in a matter of centuries, leaving behind desolate gravel plains. The engine behind the Green Sahara was not local weather luck, but axial precession, a 23,000-year wobble in Earth's rotational axis. This mechanical cycle steadily alters the distance between Earth and the Sun during Northern Hemisphere summer months. 10,000 years ago, summer solar radiation in the Northern Hemisphere was roughly 8% higher than it is today. Intense sunlight beat down on North Africa with immense energy, scorching the land surface and rapidly heating the air above it. Rising hot air over the sun-drenched continent created a massive atmospheric low-pressure system across the region. This vast vacuum drew cool, moisture-laden air inland from the tropical Atlantic Ocean, generating a powerful, rain-heavy summer monsoon system that swept far north. Heavy summer rains pushed hundreds of miles northward into areas that today receive less than 1 inch of precipitation per year. River valleys filled with rushing water, carving permanent river channels across territory now buried under hundreds of feet of sand. Thick vegetation covered the landscape, creating a powerful climate feedback loop that amplified monsoon rainfall. Dark plants absorbed solar energy instead of reflecting it, while their foliage transpired water vapor back into the atmosphere to form fresh storm clouds. Lakes and interconnected wetlands stretched across thousands of miles, creating vast aquatic migration corridors across North Africa. Crocodile and hippo populations expanded rapidly, migrating from equatorial river basins northward into water bodies that had previously been arid dust bowls. Monsoon rains reached as far north as 28 degrees latitude, transforming limestone plateaus into fertile grasslands. For nearly 6,000 years, this hydrological system maintained a stable, vibrant green equilibrium across an area larger than the continental United States. As Earth's axial wobble slowly continued, summer solar intensity in the Northern Hemisphere began a gradual, relentless decline. Over millennia, the orbital engine powering the West African monsoon lost force, steadily reducing the amount of ocean moisture pulled inland. For centuries, dense vegetation buffered the North African region against this gradual reduction in summer sunlight. Deep root networks held moisture in the soil, sustaining plant life through drier seasons and temporarily delaying the ultimate collapse of the regional climate system. Around 5,500 years ago, summer solar radiation crossed a sharp mathematical threshold in the regional climate system. Monsoon winds weakened past the tipping point where dense vegetation could survive, triggering a rapid, non-linear environmental collapse across the continent. As plants withered and died, pale soil and exposed sand were laid bare to the sun. Bright sand reflected solar heat back into space, cooling the land surface and further suppressing the atmospheric thermal contrast needed to pull monsoon winds inland. A persistent myth claims early human cattle herders destroyed the ecosystem through overgrazing, causing desertification. Modern climate models and ocean pollen records prove that orbital mechanics drove the collapse, though human pastoralists adapted their grazing strategies to the drying environment. In less than 5 centuries, annual rainfall across North Africa plummeted by up to 80%. What had been a continent-spanning aquatic paradise broke apart into shrinking oases, driving wildlife and human communities into desperate migrations toward permanent river systems. Lake Megachad collapsed rapidly as its river feeders dried up under the relentless sun. In a few centuries, the immense lake shrank by over 90%, leaving behind a vast, barren basin filled with thick deposits of dead freshwater organisms. As interior water sources vanished, nomadic pastoralists retreated toward the fertile valley of the Nile River. This concentrated human migration along a single water corridor accelerated urban density, social hierarchy, and the eventual emergence of the pharaonic Egyptian civilization. The dried lakebed of Lake Megachad transformed into the Bottle Depression, now the dustiest location on planet Earth. Billions of tons of exposed diatomite, the lightweight silica shells of ancient freshwater algae, were left completely exposed to high-velocity desert winds. Strong northeastern trade winds, known as the Harmattan, began scouring the Bottle Depression each winter season. These fierce winds lifted fine mineral particles miles into the atmosphere, creating massive dust plumes thousands of miles long that drifted west across the ocean. Shifting sand dunes crept across former lakes and river valleys, burying stone tools, pottery fragments, and rock art under hundreds of feet of sand. The vibrant savannas vanished completely, replaced by 3.5 million square miles of hot desert. In 1981, imaging radar carried aboard Space Shuttle Columbia penetrated the dry sands of the eastern Sahara. Ground-penetrating radar revealed vast ancient river channels hidden beneath the sand dunes, some of which were wider than the modern Mississippi River basin. This rapid transformation permanently altered global atmospheric circulation, shifting Atlantic storm tracks and altering rain patterns across Western Europe. A thriving world of lakes and savannas had turned into the largest hot desert on the face of the Earth. Wind erosion reshaped the landscape, carving stark yardangs into dried mud deposits and stripping topsoil down to bare bedrock. Archaeological traces of human occupation were frozen in time, preserved in hyperarid conditions where moisture virtually ceased to exist. Today, the Saharan dust plume carries over 180 million tons of mineral sediment across the Atlantic Ocean every year. Satellite imagery shows massive dust clouds traveling thousands of miles, crossing the Atlantic to reach South America and North America. Phosphorus from the ancient algae beds of the Bottle Depression falls as dust onto the Amazon basin. This Saharan dust supplies crucial nutrients to phosphorus-poor rainforest soils, nourishing the very tropical forests that replaced the green Sahara half a world away. Saharan dust clouds also play a critical role in global weather regulation. Airborne mineral dust absorbs sunlight, warms the upper atmosphere, and creates dry air layers that actively suppress hurricane formation over the tropical Atlantic Ocean during peak summer months. Deep beneath the scorching surface of the Sahara lie massive fossil aquifers containing thousands of cubic kilometers of water. This pristine water fell as rain 6,000 years ago, trapped deep inside sandstone rock layers during the ancient Green Period. Desert nations now drill thousands of feet into the earth to pump this ancient, non-renewable water to irrigate crops. In places where air temperatures exceed 115 degrees, bright green circular crop fields stand surrounded by miles of dry sand. Earth's axial precession continues its steady, slow clockwork cycle in space. In roughly 12,000 years, summer solar radiation in the Northern Hemisphere will once again reach peak strength, reheating the North African landmass and reigniting the summer monsoon. When that orbital threshold is crossed, heavy monsoon rains will return to North Africa, filling empty basins and turning sand dunes back into grasslands. The Sahara's dry sands will bloom once more, continuing a climate cycle that has repeated for millions of years.